As we approach the everyday usage of augmented reality, how can we enable adapting AR interfaces to meet end users' privacy needs? For an outdoor navigation app, the user could limit their live sensing range to avoid capturing bystanders, and maybe use crowdsourced data to supplement information outside of this range. Speech input could reveal sensitive details about where the user is going, so maybe they want to type instead. Or use a combination of gestures and speech so their attention can stay on the road. As we can observe, developing a range of adaptation techniques that balance usability and privacy is challenging, as solutions span a wide range of AR input, output, and interaction modalities. Our work systematically explores this design space of privacy-driven AR adaptation techniques in 2 steps. First, to establish the design space, we conducted an elicitation study with 10 AR researchers, resulting in an adaptation catalog of 62 techniques. Then, to enable AR developers to navigate the design space without privacy expertise, we distilled the adaptation catalog into a visualization tool and validated its effectiveness through design workshops with 6 AR developers. Let's take a look at how we scaffolded the elicitation process through scenarios and design considerations. Our first scenario involves a new resident in a city using an AR navigation app. We elicited techniques to maintain AR functionality even if the user restricts access to speech recognition, spatial mapping, or eye tracking and object detection capabilities. We also explored a remote assistance scenario where a factory worker is troubleshooting an issue with a remote expert who is located in their personal home. Here, we brainstormed privacy-driven adaptation techniques when using audio capture for verbal communication, 3D reconstruction for the worker to share a representation of their physical space, and gesture recognition capabilities. To encourage the AR researchers to brainstorm a diverse set of adaptation approaches, we established 2 design considerations alongside these scenarios. First, a permission model representing different levels of access to AR sensor data. And second, we considered whether privacy adaptations are system-driven, user-driven, or mixed initiative. This resulted in a wide range of design strategies across our design considerations, such as filtering required data features at the operating system level, rather than passing raw sensor streams to AR applications, using less privacy-invasive sensors to approximate speech or depth data, and techniques to spatially or temporally restrict sensing range. Next, to make these adaptation techniques and design strategies approachable for AR developers to navigate, we distilled them in a visualization tool. The visualizations map techniques with respect to our design considerations and provide faceted search tools to filter techniques. Clicking on the techniques pulls up additional information, including different implementations that the AR researchers proposed or cited from prior work. To help developers assess implementation needs, this visualization maps the types of input required to enable the techniques and the corresponding types of output that are produced. Developers can also visualize how frequently each technique was proposed by the 10 AR researchers who participated in the elicitation study. Through design workshops with AR developers, we demonstrated that our visualization tool allowed them to call the design space quickly and evaluate trade-offs between techniques, without having extensive privacy experience. To further lower the barrier for developers to implement these adaptation techniques, we outline future research for developer tools and community-driven updates to our adaptation catalog.